This video is about when we will not need computer programmers. Devin has recently been released an AI coder that is being sold as an actual, you can replace developers with it, and there's an implication to be that, oh, it's junior, and so it's going to pretty quickly get up to senior because of the rate of progress. But is that practical based upon how Devin actually works? There's a lot of advice and predictions going on out there. And obviously I'm going to give my own advice and predictions, but I think it's not based upon, what the stock price of my company, what I want to be true. It's based upon the actual real world data and experience and testing that me and my team have done within my company and from people who are actually thinking about this practically. So we're going to talk about what Devin is really like, and what AI software development is really like. The software engineering benchmark that a lot of these models are being released on, the LLM model improvement trajectory, LLMs improving LLMs, and the opportunities for current software versus new software that was not previously possible. So let's jump right into it. Okay, so there is a lot of advice and predictions going on around here. I love this. According to my highly unreliable forecast, we're right on track. But if the assumptions are off by even 1%, we're doomed. This is sort of like what a lot of these predictions that I'm going to talk about in a second are like. Basically, they're making these predictions that in the kind of possibilities of the future possibilities, it's a very narrow slice of what's possible, and a lot of things have to go right. And a lot of assumptions that are not proven have to be correct in order for them to happen. So, for example, Jensen Wong said earlier this year, don't study programming anymore. I don't recommend it because we won't need programmers in 5 years. I think this was actually more like a year ago. So, he's already 1 year in, and it's and it doesn't seem reasonable. But I'll explain that more as we go along. And kind of what my recommendations are. Spoiler alert, I still think it's really good to study programming. It's really good for understanding algorithms and logic, which I think is going to be valuable kind of no matter what happens. So yeah, this is a very common prediction. Some amount of 5 years, 3 years, 7 years, 10 years, something like that, no programmers will be needed. I'll explain that in my conclusions. End of programmers is near from the AWS CEO. Again, Jensen, if this is true, or even people just believing this is going to be true, whether or not it actually happens, helps him make money. Same thing for AWS CEO and a ton of other people. When you hear this, really understand that they get value out of people believing this right now. So really think about who's saying it and why they're saying it. I don't have a horse in this race, whether or not this is true or not. I don't make more or less money. In fact, I have a positive bias towards this being true because it makes my life easier in a lot of ways. But I'm not trying to sell that directly to you. And and it also, I just have an honest and integrity to the truth that whether or not it's in my interest or not, I'm most interested in the objective truth in general, because I think ultimately acknowledging that and living with that is what gives you the most value, even if in the short term it seems like it's against your interests. So even if it's against my company's interests or my own personal interests, I'll still speak the truth as best I can. And I think some people are like that, but there's, you can't always. It's harder or easier for some people to affect the incentives that are in their brands. I don't have nearly as a strong incentive as like Jensen Wong. So first of all, the original video for Devin was faked, and it resulted in a $1 billion plus valuation, which is, kind of crazy that they got away with that, and that they're still moving along. But if you watch some of the people who actually paid for $500 per month for this, it's very slow, which is not the end of the world, but really the big thing is that it works inconsistently. There's tons of times where it just doesn't do what you want it to do, or it does something completely different, or it does something completely wrong. Sometimes it does things right, and I'm going to explain to you kind of what that looks like numerically in a second. So it's generally good at solving very simple things, but it's bad at solving like novel or complex And I'll put some links in the description to some of the videos that show what Devin is really like. It's a little bit outside the scope of this video to really dig into that. But in general, I want to show you this nice little graph that was created by AI, so AI is still useful, that shows on this graph you have simple to complex, and then you have well-documented to novel, so new challenges. So in the closer you get to here, the more green it is, the more that it's software like AI, like a Devin or Cursor or ChatGPT or Claude can actually help you and is going to be more useful. So, if you think about it, even if it's just this, 1/2 of 1/4, so 1/8 of this, if we draw a line on just the green, that's still pretty useful. So I'm not saying AI is not helping at all. There tends to be some interpretation. Well, it's either going to do all the software or it sucks. No, that's not true. It's definitely useful. There's a lot of space to work in here. But the further you move up and towards the red, the worse it is. The more it either fails outright or it creates bugs that become challenging a few steps down the line for you to fix, or for the developer to fix, or for the AI itself to fix. I heard somebody call this like a trough of despair. Basically, it's like this is why if you've seen a lot of the things out there, it's like it seems like AI can just code and it's perfect. What do you mean there's issues? It's because people show the very first few steps where AI can kind of get some progress, but then it kind of paints itself into a corner oftentimes that it can't get itself out of. And so I call this sort of like runaway nonsense. It's sort of like why hallucinations happen. When it goes off track, it makes it go off track even more. So it's very, very challenging for it to pull itself out of that. And the more from a coding standpoint, we can use it in small bites, the easier it is to do this. The further you can kind of push into the yellow area versus trying to I'm just going to have it write like a whole set of code, a whole program. That is, you need to be very well into the green. And I've heard an interesting idea, which is that all code is tech debt. And so just because it can write code and more code faster doesn't necessarily mean it's useful. So let's take a look at the software engineering benchmark. Now, I shot a separate video on what the meaning of benchmarks is, and I think in general what you need to realize is that this is a narrow slice of meaning. That while there is meaning to the benchmark, it does not describe all the aspects of how coding works or what coding can be done. So let's look at verified. So what this means is can AI systems see bugs and fix them? And AWS resolves 55%. I believe this number has grown significantly over the last year. I think the top number was somewhere in like the teens or the 20s about a year ago. And so this is pretty impressive progress. However, this is a little bit like, you're with coding, you have to be right. You can't be wrong. And also this appears to be, and I'm not 100% sure about that. Is it just bugs or is it also writing new code? So I think there's a bias towards already having a lot of context for the code versus, hey, let's create something new that didn't exist before. I think that this would rate a lot more poorly on something like that, or require a lot more human intervention to create something new, just based upon how LLMs work. But also, it's like for self-driving. What if self-driving was 55% good? Would you want to release that? Like, it needs to be really, really high. It needs to be very, very high on the quality, or else it can end up even just a few percentage points of bad can poison the well. One bad apple in a big batch can poison the whole batch. And I think that's very similar. It's not quite as extreme as self-driving, but it's still very similar because one little bug, especially like a bug that's like little and it's not obvious at first, and it's not a bug that happens every single time you run, that can create more work than it helps. Okay, and so this is important. But Amazon's dumping a bunch of money in here, and then Devlo is kind of like a similar thing to Devin, I think. And I'm sure that there's a bunch of other companies doing this, and I generally appreciate this work. But even though this is not a perfect metric, again, this doesn't have all the meaning. If this was to 100%, would this mean that we don't need software developers anymore? I don't think so. I think it again, it's a narrow scope, a narrow slice of the meaning for whether or not AI can really move forward with software development. I'm gonna skip this one right here. Runaway threshold. So if we go back to this, what is the threshold to where this kind of runs away with itself? I don't really know, but I think it's very high. And again, this has to do with not just like this number does not mean that it does 55% of all software correctly. That's not exactly what this means. And so, but I imagine that, you know, once if we can get this to like 90, 95, 99, one of those three numbers, that there is a point where it's like, okay, this really can do a lot for us, or at least it can fulfill certain types of software development roles, and there are multiple types. So you could have just somebody, it could just like be constantly searching for bugs, and that's all it does. It doesn't create new software. That's going to probably be the most challenging. And to be honest, I think we need a new paradigm in order for the AI to actually come up with new stuff, because the way the LLMs work, they can create new recipes, but not new ingredients. That's really key to understand. So it can remix ingredients in novel ways, but it can't create new ingredients. And so as long as that's true, I think it will definitely need some humans. Okay, and that's kind of what, you know, I think that this is hard for a lot of AI fans to believe, and so when they hear this, I've gotten some violent reactions. But you know, this isn't just coming from me. I shot a video a month or two ago about even coming from techno optimists, Andreessen Horowitz. Those are two guys that are very famous VCs, very integrated into tech, you know, very nerdy, and they said basically that there's no examples of an LLM improving itself, and that there's been a significant slowdown in improvement for large language models, so the models themselves, since GPT-4. This doesn't mean all technology, this doesn't mean all the connected technology AI has necessarily slowed down. That's not what I'm commenting on one way or the other, but the models themselves have not improved much. And if you're like, well, O1's so much better. Well, first of all, the difference between GPT-4 that came out in April of 2023, so about a year and a half ago, versus O1 is not nearly as big as 3 to 4 or 2 to 3. Okay, but it's also not comparing apples to apples. It's comparing apples to strawberries when you compare O1, because O1 is not just a model. It is a process that kind of loops on itself, that does basically some variant of chain of thought. So it is not just the model. They've improved the model, yes, but then they're putting it into a bigger process, which I think does need to happen, which is separate from the models themselves. And I think that this is missed by even a lot of technical people, and you can see the way they talk about it when they say the O1 model, the O1 model, the O1 model, because there is a model here, but it's more than a model. Okay. But really, it seems like there needs to be new tech innovations on the model side for us to really take this to the next level. And my reason for that is it's not just that LLMs have not improved themselves. The LLM itself is about the same, plus or minus 10%, 500 lines of Python code since 2017 when Google released its paper. Really think about that. Humans haven't even been able to improve it yet. Now, that doesn't mean that there isn't a model improvement, like little bits in here and there. And you're like, well, why did it get better? It got better because of more compute and more data. That's really what it comes down to. And not just a little bit. Like, they took that to the, gazillion times more. But they've run out of data, essentially. And this was obvious to me even last year, that they're running out of the data. They basically used all the data they could to make GPT-4, or it was very close to like all the data that was possible for them to gather. But then compute just is getting more and more, it's getting less and less expensive, but there's a much more demand for it. So there's a limited amount of compute. They can't grow the compute 100x every year, which is kind of what they did with the previous versions. And so in order to also, I think the other aspect of this is just the fundamental way that LLMs work limit its ability to do novel things, for example. We need something that can create new ingredients, and the current technology cannot do that. So in reality, the most practical expectation going forward is that we'll be stuck with marginal improvements on LLM technology, on the models themselves, for quite some time. I think it could be another 10 years. And I think that's actually more reasonable than saying, oh, we're going to have something that's 1,000 times better in a year or two, which is what a lot of people are expecting. And I don't think that's practical. I don't think the data, I don't think the reasoning, I don't think the evidence points to that. I think it points actually to the opposite. But a lot of the major voices out there, like Sam Altman at OpenAI, and Google, and NVIDIA, and Amazon, they have a vested interest in pumping the value up as high as possible. Now, it paints them into a worse and worse corner over time. So, to be honest, I think that they should. I would think it's in their interest to actually kind of slow their roll a little bit and not get too far ahead of things. But in some cases, I think OpenAI is on like a runaway train. Like I think they can't back up and say, you know what, actually I think it will slow down. That would crush their value, and they'd have potentially like investors suing them. And you know, I guess I already talked about a lot of this, and OpenAI's bet that they were successful on. So I already mentioned these two things that they were successful on was, hey, if we make these neural networks, the transformers, which is a type of neural network, just really, really big, throw a ton of compute and a ton of data at it, it will get a lot better. And they were right. So they get a lot of credit for that. But that doesn't mean now people go, okay, well, they were right about that, so therefore they're right about everything else. I don't think that's a very reasonable way of looking at it. It's not completely wrong, but we also have to kind of look at the data objectively and what their incentives are, and their incentives are to say, hey, we're going to keep this train going. Here's another thing that I don't hear anybody talking about. Number one, the current software that we have right now. So just take all the software in the world. There is a ton of opportunity to put AI in it to enable it to do more or better or faster or cheaper or whatever. There's a ton of opportunity there. But I think you take all that software and you at least double it, and there's new software that wasn't possible 2 years ago. So to me, this means there's tons of opportunity for software development, and there's lots of new work that needs to be done. And most of this work cannot be done by AI. Think about that, especially for the new things that weren't possible before. There's nothing in its training set for this stuff. So how do you think the AI models are going to do this? It needs to come from humans, at least to some significant degree. And the more complex and challenging and novel it is, the more it needs to come from humans. Or, again, we need a completely different, a major transformational change in the models themselves, which does not look like, which could take many years. Maybe it happens in 2 years, maybe it happens in 20. No one really knows. And it's to suggest, to imply that it's definitely going to happen in a couple of years is just irresponsible. So here's my conclusion. When will we not need computer programmers? My thought on this is not anytime soon, if ever. And I think I've made my case in all the above things. I think even if we have another evolution, the value of computers, the value of even just collaborating humans, even if it is very high, because even if we get like another technology, I would expect there's still going to be limitations to it, that humans have advantages over it. And the AI will have advantages over humans in certain ways, but it won't necessarily be in all the ways right away. In fact, I think that's going to take probably at least 20 years, if I had to guess. But if we're stuck with this technology as we have it right now, we actually will need more computer programmers, and there will be more value. So, as I pointed out on the previous slide, there's a ton of new work that can be done. The value of AI right now is very high, but it's people are taking it from, it was kind of a parlor trick 10 years ago to now it's like I'm going to do everything and be everything and eliminate all the jobs. It's just like slow your roll. Like they don't know how many steps up the chain we need to really get to that peak moment. And I think they're underestimating how much more work needs to be done. But as I pointed out, all the software we have right now can have AI embedded in it, pretty much all of it. And it's possible there's a small percentage that it doesn't, but it might even be 100%, 99% plus. But then there's way more new software that can be built, completely new, that just couldn't exist. And so there should be more demand for computer programmers. So the idea that don't study computer programming. To me, that is absolutely terrible advice. That is one of the worst pieces of advice I've ever heard. Even if this technology really grows a lot, the ability to understand how it works will create value and an opportunity for you, even if you don't actually program. So even if in this world where we have new technology, let's say we need 2 or 3 more massive transformative technology improvements, and we get there really quickly. Let's say for some reason in 5 years they're absolutely correct. It still is valuable to understand how computers work. That's going to come in handy no matter what, because you're going to be able to understand what's going on, and you're going to be able to evaluate the real value. And in the most likely scenario, you're still going to be in demand, and your understanding of how the world works and how the massive quantity of valuable software, what it does for you, is going to be valuable. So please ignore a lot of the things that, oh, we're not going to need any computer programmers. It's pretty much horse shit. And in the extremely unlikely scenario where AI does all the programming, it still will be valuable to understand and have experience around coders. In fact, you might be that much more rare, as a lot of people are believing this nonsense that we're not going to need computer programmers anymore. So the amount of programmers is maybe even going to go down, or at least not increase at the rate that it was before, as people hear this advice and go, oh, well, what's the point? And they take the bad advice. And the demand goes up, and the value of what computer programmers can offer, it goes up. And the more people that can actually work in this area, the more you personally can do that, the more valuable you'll be. Period. End of story. There's no scenario other than like Armageddon, other than like all of technology getting destroyed. Unless there's like some sort of reset button. That's the only scenario where this skill set is invaluable. Every other possible future, knowing how to code, having experience coding, having experience actually thinking like a coder, is going to be valuable. And most likely it's actually going to be more valuable as there's going to be more demand and potentially less supply, or at least less growth in supply. So let me know what you think. Please like this video if you liked it. Please subscribe for more like it. If you disagree with any of the points in here, please feel free to put a comment. Happy to talk to you about it. If you agree, also leave a comment. That's great too. And let me know, or if you have any context to any of these situations that I've described, happy to hear your thoughts on that, even if it's different than mine. Thank you very much, and have a great day. Bye.